Good afternoon. In this video we're going to explore curve fitting in ZebraCut. Now if we have a look at this curve here, it may look very smooth and very fluid and therefore very easy for the machine to follow, but if we zoom in you'll actually start to see that it's composed of a large number of short segments, short straight lines, and so that can make the motion of the machine very jagged. Indeed, if I move the control points, you'll see you get very jagged, very sharp edges to the shape. Now there's a whole variety of ways you can repair geometry like this. We're going to use a preparation step within ZebraCut, which is called Fit Curves. You can find it under Geometry Cleaning, Fit Curves, and you can then add the step to your preparation pipeline. It has several settings, and the goal of these settings is to essentially start quite high and then work down until you've removed the distortion that you're seeing. So to show us how this works, I'm going to create two copies of this geometry. So now I have two curves, and I'm going to change the display color of one of these to be a custom color, and we're going to make it one green, and then we'll also have another one which is red. And we're going to work on just the selected geometry, and we're going to work on the red curve, and then we'll be able to see what distortion we're getting compared to the original one. So the three parameters are as follows. What is the maximum angle that you're allowing the curve, the new curve, to deviate by? If you have a lot of kinks in your polyline, you need to use a large angle, but in general for quite smooth geometry like this, the angle between the different segments on here is actually quite small, so we'll start with a smaller value. The most important value parameter here is called fit tolerance, and this is the maximum amount of deviation that you're willing to accept when we create a smoother curve. If we plot a smooth curve through here, it will deviate from these straight lines in order to make a smooth curve. So we need to accept some level of deviation, and the larger the fit tolerance, the more scope the algorithm has to play with to give you a smooth curve. And the key point distance, well, what this does is it ensures that straight lines remain straight. If we use the analyze distance function and we figure out how long this one is, this is 127 millimeters. We want that to remain straight. So we want our key point distance to be about the kind of the same, roughly the same as the smallest straight line that you wish to keep. So we're going to start with these parameters and we'll see the impact that we have. So we'll just run it on the red curve and we'll press apply. And you'll see now we get some nice smooth curve in red. You'll see it's much smoother. You can see it's also a spline because when I move the control points, you'll see the whole curve is impacted and is still a nice straight smooth curve. So you will get some distortion. It's never going to be exactly the same, but you'll see in general that distortion, if we go analyze distance between there and there, that distortion in this case is about 0.2 millimeters, a bit larger down here. So here we're looking at 0.6 millimeters, and you can see our straight lines have been kept straight. So really it's up to you whether that distortion is good enough. If it's not, we just press Ctrl Z. So we're back to our two lines with lots of small segments. And we can reduce the fit tolerance here maybe down to 1 millimeter. If you found that you were getting a lot of distortion on the angles, you might look to reduce the angle tolerance. And as I say, if the straight lines that you want to keep straight are being distorted, you need to reduce your key point distance. But in general, keep these parameters nice and high and just see what effect they have by doing it on one copy of the geometry. We're always going to be able to compare to the original geometry and we can look at analysing the distance between the old and the new. So 1.6 millimetres. The fit tolerance there is actually measured at the ends of the curve, so the centres of the curves might move a little bit. So in this case, if I want to try and bring this bit here in a bit and keep this straight, if I just press Ctrl Z, if I reduce the key point distance maybe down to 50, I think we'll get a better fit. Let's try that. So yeah, we're now starting to get a little bit of a better fit to better fit to that. But now we will find that some of these curves will actually end up being kept, even though we want actually to curve them. So we could perhaps even try a lower tolerance, and we'll just see what we get from that. It is always going to be an art rather than a science for curve fitting. So that's giving us a reasonably good fit. I mean, the more you zoom in, the more you see. But if you actually look at the distance that's out from the original curve, it's 0.5 millimetre, so barely noticeable. Let's try it on another example. So we'll delete this fit curves and we'll go back to the standard parameters that come with it, and we will run this. And you'll see we do start to get strange distortions in those notches. So what I'm going to do is I'm going to do a few measurements. So analyze distance. This notch here is 5 millimeters across and about 5 millimeters long, and the segment there is about 5.5 millimeters. So I'm going to make my key point distance to be about 2 millimeters, maybe 3 millimeters, and I'm going to have my fit tolerance to be, let's say, 0.5. My angle tolerance, there's no really kind of crazy distortions in here, so I'm going to keep quite a small angle tolerance, and we'll just try that and see. And there we go, we've got a much smoother curve, and you can see the key points have been introduced every 2 millimeters along those notches there, and those are what maintains it. So if I undo that and do it again with a larger key point distance of maybe 4, you'll see actually I only get a couple of points along that. So if I do it with a key point distance of 10, I may end up getting distortion on there. Let's try this example. So again, this has got polyline segments. So if we move those points, you'll see we get quite large distortion. We'll go back to the original settings, and we'll just make 2 copies of this and work on one of them. So fit curves. Now I think we're going to need quite a large key point distance, analyze distance. These are about every 185, so we'll do an 80 mil key point distance, and our distortion distance, I'm going to allow this to be quite large. Let's go for 5 millimeters. We want this to be a lovely, smooth, flowing curve along here. And the angle tolerance, I think probably 50 is a good number. So if I do that, you'll see we now have a version of this which has a nice, large, smooth, flowing curve, which is what we were after. Of course, we do sometimes end up with distortion on the corners. If we undo that and try and control that, we can look at trying to decrease the angle tolerance. Maybe that would help us. Trying to take that down to 25. And now we have got a much smoother curve, and that's basically avoiding that angle change here at the top, which is maybe only, what, 35 degrees, but because 35 degrees is larger than 25, we'll keep the nice sharp point up there. Maybe you get a slightly less flowing curve here, but it's always going to be a trade-off with curve fitting. Make 2 copies of this, and we'll just run this again on one of them, and you'll see we still maintain the nice smooth curve. Select the curved one there, and you see that's nice and smooth, and you still maintain the sharp point. One last example then. On this one we have these points here, which again are polylines. We really want that to be smoothed. So we'll again delete this, add the step again, and we'll start trying to tune this to be correct. If we just make 2 copies of it, and again I'll make one of these a different colour, one red and one blue. So we'll work on the red one and see what difference we get. So let's just try the default settings, see if there's any distortion that we don't like. That's pretty good. That's a nice smooth curve, and you can tell it's a curve because as you do that, it affects more than just that local area. We're going to get a bit of distortion here. I'd rather not have that. If we look at analyze distance, that distance is about 100 millimeters. I suspect we need a slightly higher key point distance. You want to keep the key point distance to be larger than what you were seeing between these points that you want to smooth, but it needs to be less than the distance of the straight lines. So if I analyze that distance there, we can see these are about every 30 millimeters. So we want to probably make a key point distance larger than that, and the straight we wanted to keep was 91. So if we go for a key point distance of maybe 50 mil, and again if we just undo that and we select our red one, we're in selected geometry mode, we press apply. Oh no, that's not quite worked. Let's try and just reduce that again, maybe get down to 40 or so. Still getting distortion. Let's try a different parameter. Let's try reducing the angle tolerance down to 15 and hit apply. Nope, still getting that. Let's take the fit tolerance down as well, so maybe down to 1 mil and hit apply. That's pretty good. Maybe we need to try and increase the key point distance down to 20. Let's just see if that gives us a better figure. That looks better. We are getting less smoothing up here, but we still have an actual curve here that's quite nice. So in general, as I say, this is always really an art rather than a science. It is generally a case of just starting with the defaults and then reducing these figures intuitively or iteratively until you no longer get the distortion that you're uncomfortable with. It's always going to be an art. The only other way of getting rid of this kind of problem is to redraw the geometry using the Rhino tools. But in general, fit curves is a pretty good solution to what you need to do. Sometimes it's useful to break up the shape into multiple curves and use different parameters for different parts of the curves. Obviously you have to do that manually, but sometimes that can be a really handy way to resolve things. If you do need to redraw, the easiest way to do that is going to curve, freeform and interpolate points. So I can ask for it to have a point there, a point there, a point here, and you'll see I can actually redraw this. I can just press return, and then I can obviously put in my lines and keep them perfectly straight where I need to do so. Oops, one there, and then another line back down here. If that was meant to be straight or if it's meant to be curved, we can obviously put in a curve as required, and then we can run a join on those as required. But realistically, if you can use fit curves and tune it to your geometry, that'll be much quicker. If you do need to redraw, Rhino is a great package for redrawing. But I hope that's been helpful, and please do get in touch if you have any questions.